Good morning to all. So, this is the class we are talking about the mechanics of solids. So, mechanics of solids talks about the link between the design engineering and the analysis wing. It is also called as the analysis wing of the design engineers. What is the importance of mechanics solids in mechanical engineering? We will get to know at the end of this course. When we will reach at the end of this course, we are going to understand how it is important for a mechanical engineer. Mechanics of solids only not be studied by the mechanical engineers, instead it has been studied by the all different kind of engineering branches, where design is one of the major part of that, like civil engineering, biomedical engineering. According to their material, it has been changed, the solids and solid behavior has been changed. How the solid behavior has been changed and how the solid behavior can be incorporated in the mechanics based, it has to be understood by this course. By end of this course, we can able to understand various point, including the specialization I have written here, like solid mechanics, material modeling, multi-scale modeling, theoretical and experimental mechanics, biomechanics, smart material, structural acoustics, structural optimization. All these kind of studies, or all these kind or one kind or every kind studies can be constitute without knowledge of mechanics of solids. It is not possible as per my understanding, and slowly you can understand that how it is important for all different kind of studies. Now, the mechanics of solid is the syllabus. I am talking about the syllabus. When I am talking about the syllabus in your course, this is the definition of stress, stress tensor, normal shearing stress in axial load. You can see there are two different colors I have given. First part of the color will be discussed before the up to the mid sem, and after that the black color will show you the after mid sem of the part. And we will go little bit slow the first part, then slowly we will go into the problem and problem definition. Because the mechanics of solids is a course which is a blending of both theory as well as the experiments, and how first experiment was there or the theory was there, or first theory was invented then experiment has been done. Likewise, there are various query will come in between, and we will discuss how the history of the mechanics of solids says. First of all, people do some kind of experiments, and after 100 and 150 years afterward, somebody has given some mathematical relationship to the same experiments, and it has been expressed further. People have utilized those theory as well as the experiments as the benchmark solution later on, and it has been utilized in the various phases of the design engineering. Now, definition of the stress, all this kind I will come to later. Before that, as the name suggests, mechanics of solids. What is mechanics and what is solids? Before going to that, I need to discuss little bit on the course syllabus, as I have discussed how the course and what are the books you will utilize. These are the some books has been shown here, and most of the books you can find S.C. Euler, which is available in your Google. You can go get in Google, or except this also you can go for the some NPTEL courses. I have not mentioned here. You can also search in Google and you will find it. And for the Indian authors, those who are interested for the Indian author, they can go for Strength of Material by S.S. Ratan. It is a very good book. You can utilize that book, and you can, and some of the theories and some of the explanation you can see the E. Popov or S.C. Euler, or Elements of Strength of Material by S.P. Timosenko. It is also a very good book, but some of the part, as I said, it is S.S. Ratan will constitute our whole syllabus. You may find in S.S. Ratan, and some of the reasoning or explanations can be seen in the Subramanian. And after the books, what are the mark and how the evaluation process? The total 100 marks will be evaluated. I think most of you know how our evaluation process is. This is end semester 50, mid semester 30, and TA is 20. And this is the class performance 20 is talking about how this class performance will be evaluated. Just below I have explained how the class performance will be evaluated by class test, by performance evaluated on the basis of 2 or more assignment, 2 or more class tests, mostly surprise type, but I do not think that this time or on during this online period it will be also discussed in that when the class test will be performed. Then utilizing the software available in our institute, we can utilize how to find out the bending moment diagram, bending, deformation and shear force bending moment diagram by using ANSYS, Abacus, and problem using MATLAB code based solution, and now also we are looking towards Python coding. If somebody is able to do some abacus kind of code and how to model it by using Python coding, because abacus give the supports the Python coding, and you can utilize, or you can able to get this Python code from the abacus directly. Additionally, we can also find out the properties by using properties of different material by using Digimat or Digimat implementation, and Digimat we have purchased newly, we have purchased Digimat, and how the Digimat digital matrix, or how this Digimat of the material can be evaluated in the Digimat. It has be if somebody is interested, then we will discuss after the class or above the over and above the class. It is not within the class, but these are the extra strength we can generate, or we can improve during this course, will help us to improve that. Now, the class timing, as it has already been discussed, so already been shown, I need not to discuss on that. Now, I am coming to the this term, this mechanics of solids as I is given. So, mechanics of solids can be also called as sometimes strength of material, sometimes called as mechanics of material, sometimes it is called as solid mechanics. So, all these names are not synonyms, but exactly if you will see the course I have shown here, the syllabus have some kind of differences based on their strength, based on their mechanics, based on their material, based on their solids, it will be changed, and the syllabus will be designed accordingly, and the name is suggested. Now, here both mechanics of solids, both mechanics as well as solids has been taken into consideration, and the syllabus has been prepared accordingly. Now, I will come to directly to my during these courses, these are the some of the achievements we have found. People have interested to work on this based on this mechanics of solids idea. We able to do at least 2 different patent. One patent has already been in the verge of getting some kind of final decision, and one more we have already. It is a bending fatigue creep testing machine, which is for flat composite specimen. It is a bending type fatigue or creep machine we do not have exactly for the composite material, but other conventional materials are there. So, it has been filed and it is already published in April, this April only. Now, we are looking forward for low cost energy efficient material, ultra lightweight material, and small product to help understanding human heart health. We are also working, some group of people are also working, those who are interested, they can be added into that. Now, mechanics of material, before coming to the mechanics of material, when I am saying mechanics, we know, all of us we know what is the definition of mechanics. So, mechanics is a just a combination of motion and the cause and effect. So, most of us we know how the mechanics has been developed. Slowly the mechanics, you have studied the mechanics earlier, and you have also studied part of the material in your earlier classes, or up to +2 you have some kind of idea, and also just nurture those part before going to our exact theory. The mechanics you know from earlier days. Based on that, we know it is just a force, and due to the force what are the deformation, or what are the effect, or due to the force there is a motion, or the study between the force and motion, or study between the cause, if the cause is the force and the effect is the motion or deformation, whatever. Till yet in mechanics we have discussed only about the motion part, but we have it is silent about the deformation part. Mechanics deals with the only engineering mechanics, or the mechanics you have studied, it is only dealing with the part, it is called the rigid bodies. That means, it is inside the deformation, or the material deformation inside the whole body has not taken into consideration, or the straining of the body has not taken into consideration. Whereas when I am talking about the mechanics of material, it also takes the consideration of the straining of the body. It is also called as a deformable body. The mechanics of the deformable bodies are called mechanics of material. Now, if I will go to I have given some kind of like how this Galileo, Kepler, Newton has gave some mechanics or classical mechanics ideas. Slowly it has been improved, and as I said earlier also, the mechanics of material is a blend of both theory and experiment. How I will come to that, I will discuss about that. Till yet I have not discussed about that. Now, whatever mechanics you know earlier, now if I will see the mechanics, it is broadly classified into 3 major components, like theoretical mechanics, computational mechanics, and applied mechanics. What does it mean by theoretical mechanics? I think most of you know about theoretical mechanics, and you have studied the theoretical mechanics, statics and dynamics and computational mechanics and applied mechanics. Again, then how can I differentiate this theoretical mechanics? These three, when I am talking about the theoretical mechanics, computational mechanics and applied mechanics, all these three, how they are linked with each other, then how I will define this theoretical mechanics with the computational mechanics, how the computational mechanics with the applied mechanics. Leave about the bottom part we will discuss about that, how computational mechanics has been classified and all, we will talk about later. First of all, I should give an example. I am giving an example. That example can clearly define how theoretical mechanics is related with this computational mechanics and applied mechanics. If I will give a small example, like a person having a problem means not is in-house problem, rather it is an engineering problem. A person having an engineering problem but does not have a solution. A person having a engineering problem but does not have a solution, but to obtain its solution to that engineering problem, to obtain the solution, if I am taking the help of a computer, because I cannot get the solution by using my own analytical analysis. So, that is called this computational mechanics is talked about a person having a problem, but does not have a solution, and if for that solution, if it takes the help of a computer to solve that problem, is called a computational mechanics. And a person having a solution but does not have a problem. How it is possible that a person having a solution but does not have a problem? That is called applied mechanics. What is applied mechanics? The person having a solution but does not have a problem. So, how to say, let us say if I will give an example in this way, all of you know regarding a wristwatch. If I will see, if you have your wristwatch now, if you will see the wristwatch, or if you have a mobile, everybody nowadays we are using mobiles. If you will see the back side of the mobile, inside the mobile a circuit design is there. But when I am looking into the circuit within the mobile, I can know that yes, this is the circuit of this mobile. Now, I will just go to the market and I will get a circuit, any circuit, I can get any circuit, but I cannot say this circuit can be utilized to, this circuit is a solution. And if I will say, as I am saying regarding this watch, if I will go to the back side of the watch is majorly filled with a gear and gear trains only. If I will see the gear trains and if I will take it out and if I will individually take this all components, I can see there are pinion and gears. But that pinion and gears, when somebody will ask you to make, you may able to do that with available facilities. If you have the facilities, you can able to reproduce the same. But by joining those, you cannot say this gear has the solution or this gear is for a particular watch or particular kind of toys or something, we cannot say. But we can say yes, these are the gears only, and we can reproduce the gears. But for what cause the gears has been made, nobody knows. Now, if I am reproducing the same, but I can able to do the solution, I know the solution, but I do not know for what problem, then the theoretical mechanician comes to the picture. He is the theoretical, as it is says as theoretical mechanician, he will use the theories and axioms which is available. That means like n1 by n2 is equal to d1 by d2 or number of teeth. Accordingly, he will just establish this gear has this number, these are the pinions and these are the gears, and this pinion has this number of teeth. So, accordingly by utilizing the laws and axioms of the theoretical mechanician, he can establish this problem has this solution. However, in the earlier case, computational mechanician has a problem but does not have a solution. The second part of the person having a solution but does not have a question, and the theoretical mechanician is establishing this question with the solution. So, all together this theoretical mechanician, computational mechanician and applied mechanician will comes under the mechanics. So, we have already completed the first part. All of us we first initially talked about the theoretical mechanics, but now these two part and applied mechanics, basically as it is a solution part, most of the experimental parts comes under the applied mechanics or some mathematical modeling, likewise it will come to that part also. But majorly this computational mechanics again broadly classified into three: nano mechanics, continuum mechanics and the system. Before going to the nano and continuum mechanics, I will talk about little bit system. And you will also understood the system when you are talking about the system. The mechanical engineers, again they will also study thermodynamics. There is also you will study the system, that system, the theoretical thermodynamic system as well as the mechanics of solid system or the engineering system is a little bit different. How it is different? The definition or the expression of the system is different. When I am saying system does not here system means a engineering system. What do you mean by engineering system? Engineering system talks in this form, it is the aggregation of all kind of engineering. Like when I am saying automobile, let us say if I am talking about a car, only a simple car. If I will talk about the simple car, you see a car is associated with electrical engineering, it is associated with the thermal engineering, design engineering, chemical engineering, material science, civil engineering, all kind of engineering, physics, chemistry, mathematics, all this kind, aesthetics, ID, all departments are associated with the system. If I am talking about, that means automobile engineering is an association of systems, all different kind of engineering as well as sciences. The system does not differentiate this is science or engineering, or a system requires help of everything to make a system or to complete a system. So, now similarly the nanomechanics and continuum mechanics, if I will talk about the nanomechanics, what do we mean by again nanomechanics? The most of the things we are studying now, majority in majority, and all of us we have an idea about the Hooke's law, and I think most of us already studied from the +2 itself. We know about the elastic behavior of the material, Hooke's law, stress strain diagram, all these kind of things we know about that. Now, day to day, every day to day life, we are going to use whatever the shape and sizes of the material we are using earlier. Now, the shape and sizes and the volume has been going low and low and smaller. So, it is going small and smaller. So, that has a different kind of mechanics is necessary to discuss about the mechanics behavior or mechanical behavior. So, for that nano, or it is also called as nano or micro mechanics, as I am going down the scale down the material, the structural or the mechanical behavior changes. So, we will not discuss about the nano when we will talk about the nano mechanics. If we will discuss some kind of analysis or somewhere during in between the, not within the course, outside the course, if we will discuss, then I can discuss about the nano mechanics differently. Now, the continuum mechanics, our major focus in the continuum mechanics, which is also again classified into major three, solid or structural mechanics and fluid mechanics and multiphysics. What does it mean by multiphysics and what does it mean by solid? If, and we will also focus, we will only focus on this first part, it is not also in our lookout, this point is not going to be discussed now. And fluid mechanics will be again dealt higher semesters under this continuum mechanics, but fluid mechanics comes under the continuum mechanics only. The solid and structural mechanics we are going to discuss about that. The multiphysics, when I am talking about the multiphysics, what does it mean by multiphysics? The combination or the interaction between the solid and fluid is called the interaction between the solid and fluid is called the multiphysics. The solid structural behavior and the fluid behavior interact with each other, and a coupling, there is a coupling in between the solid and fluid, it talks about the multiphysics. And solid, how to analyze the solid, how to discuss, how to model the solids, we will also know about that. I have not discussed about this dynamics, which you know. So, that is why I need not to go much on this kinetics and kinematics, because our part is not this part, rather our discussion is mostly we will talk about the solid structure and structural mechanics. Now, if I will go to the next, the history, as I have already said, it is a combination of both two, theory as well as. If you will see, interesting thing is given here. Leonardo da Vinci in 1452, first he has given some idea or some experiment, or you see these 2 years, there is nearly 70-80 years gap. There are two different scientists or two different people have given two different kind of idea about the strength of wire, how to find the strength of wires, bars of any beam. But actually you see these things are only directly they have given some experiments and some experimental idea was there, but there is no theory, adequate theory by this. So, that is why it is called, it is a initially, or I initially have told it is a blend of both. So, you cannot say it is a purely mathematical, cannot say it is a purely experimental. So, it is both the things are required, because any physics occurs in a physical world has to be rewritten, or if I am interested to write the same, I need the help of mathematics. Like all of us we know the line equation, when we are writing line equation, the straight line equation we know dy by dx, likewise y1 minus y2 by x1 or y2 minus y1 by x2 by x2 minus x1, the slope, all these kind of equations you know. Also we will utilize similar kind of mathematics here also during the discussion of the other module of the course, like shear force bending moment diagram. When we will come to that, we will discuss more on that. I will discuss about the physics of the same, and theory and experiment, as it has been written, you just see theory and experiments both are equally important, and according to our course, this the experimental part of this course will be discussed in a 4th semester. Whatever the theories we will learn now, we will discuss about the same experiments will be discussed later on. Now you just see, as I said, it is a 70 years gap, 2 different people, 80 years gap, 2 different people have given the same idea in a different way and same idea in a different manner. Now immediately after 100 years of the same, whatever the experiment was done, after 100 years Leonardo Euler, who has given the mathematical expression, there is nothing, no relation between the Galileo Galilei and Leonardo da Vinci, whatever they have given the strength of the experiments of that, there was nothing. Simply he has given some mathematical equation during his tenure 1744. That means, and again it is again interesting that the whatever the you see, long before no experimental evidence existed to show the significance of his result, but he has given some mathematical relevance, and he has not also compared these relations. He has not compared the deflection of the wires or the strength of the wires by whatever he has given in mathematics. He has not given, he has only given some mathematical expression. Now 100 years back somebody has given some experimental part, 100 years after that somebody has given the theoretical analysis, and again 50 to 60 years afterwards or 100 years after 100 years, then this Euler formula, which is the most important formula, is utilized to analyze any kind of design. If there is a column design, there must be taken the Euler is the first rule has to be implemented, or to find out the critical loading of any column or strut. Euler buckling load or Euler crippling load in our subject, also in our this particular mechanics of material, we will talk about the crippling load and buckling load. Now we are not going to discuss. As your first of all, the very first slide when I have shown, or the course of studies I have shown, at that course of study first is the definition of the stress, how the stress is going to how to express the stresses. We know various kind of stresses in our life. Normally we have different stresses. Is the stress the same, similar kind of stress, whatever the mental stress we are talking about? The mental stress, if I will talk about the mental stress and the physically any material expressing stress, more or less same. We are living material, we have some soft tissue, and we have a soft material with a different kind of elasticity, expressing some kind of stress. It is deposited in some kind of chemical reaction, but here in the material, when I will say, some of the materials also having that sense. So that is why today, or most you might have heard about the that is called smart materials. They are smart, like what does it mean by smart? Something which can sense as well as actuate, which we are doing very smartly every time. Human beings are human beings has very smart natures. They are they have the capability of sensing as well as actuating, and some materials which are not living in nature, but they can sense and they can actuate. And the stresses and how it happens, that means when it is sensing some reflection, then actuating according to that reflection, and when it is actuating, the actuation based on some kind of stress or some kind of force flow and some kind of deformation occurs. So how it has happens and how we will define what is the basic, we will discuss about initially at the very initial phase of the class. Now what are the applications? The broad applications, as I said earlier, this broad application of this course has been all this kind. You see, civil engineering, you just name a department which has no use of this mechanics of solids. Civil engineering, nuclear engineering, mechanical engineering, chemical engineering, biomechanics, material science, any engineering we will talk about, including this nanotechnology. And when I am talking about the nanotechnology, design, wherever you just see, wherever the term is talking about, everywhere the design is basic. So if I am talking about design, without mechanics of solids you cannot have a design. So it is, that is why it is called analysis wing of the design engineers. So, mechanics of solids is basically a analysis part or analysis, it helps us to analyze what kind of load. Finally, we are finding out two things, or our input is load, output is displacement, or input is displacement and output is load, likewise something. That means first egg or first chicken or first chicken then egg, accordingly we will change or accordingly we will find it out which one is the most common kind of things we can able to do and which one is it easy for us. Engineers always find an easy way to define anything, and not only in the mathematical part, but also in a physical day to day life. Engineer does not mean engineering does not mean only if I will go by very common meaning or dictionary meaning of engineer. Engineer talks about a person having knowledge in the person having in charge of machines and engines called as a engineer. Others not the scavengers, they are also engineers. Then anybody who can have some like as I said is a smart in his job and he can do some kind of like bioengineering. Bioengineering means if somebody if I will talk about a doctor and engineer, without a combination of a doctor and an engineer we could not have any kind of material or the instruments we are using in medical engineering or medical sciences. In medical sciences you see sometime it is called as medical engineering, sometime it is called as medical sciences, sometime it is called as medical imaging. So, is this different than the other imaging? No. They have the similar kind of property or they have the similar kind of behavior. To analyze the same we need some kind of engineering tools to be utilized. So, we can say mechanics of solids is a tool for the engineer for whom anybody who wants to design whatever he will design. Now, materials. So, mechanics of materials, one part is mechanics is over. Now, it comes the materials. Whenever we talk about the material, it comes to our mind because every day we use a different kind of material. In our household we are using some material. When I am having a bicycle or I am just riding a cycle, I am riding a bike, a car, all different instruments having different kind of material. I am playing with some bat, I am playing with something having some relevance with the material. Without material it is not, nothing is there. So, if there is a physics, so physics also says that the object and the light. So, if there is object has some matter and matter has some material, what kind of material? There are various classification of the material. The we have shown here, it is one kind, and the below you can see material can also divide elastic, elastoplastic, plastic and ductile, brittle. When I am saying isotropic material, what does it mean by isotropic material? It is already the definition has been said here, material which has all mechanical and physical properties are same in all direction, but does not vary with the space. What does it mean by does not vary with the space? I will talk about that. And in strength of material we will discuss about that, or the mechanics of material we are going to discuss. We have some set of assumptions, and under this assumption we have all these analysis are based on these two. The material has to isotropic as well as homogeneous. Then you see, you just point out this one, it varies with in all direction, it is same in all direction, but varies with space, However, the same thing, homogeneous material which has all mechanical and physical properties are same in all direction, but not varies with the space. What does it mean by varies with the space? That means I can say all the homogeneous material can be a isotropic material, all the homogeneous material can be all the homogeneous material can be called as isotropic material, but the vice versa is not true. This is not true, but it can be possible. How? What does it mean? That means when I am saying homogeneous to isotropic it is possible, but when I am saying isotropic to homogeneous it is not possible. I am giving you an example like this. Let us say I am taking a beam. And I am taking a beam, and under this beam on this beam I am taking points 1, 2, 3 and 4, and this is I am saying P1, P2, P3 and P4. And the properties when I am saying in all direction, when I am saying about all direction, I am just drawing some lines. So, those lines are talking about all the direction, different random direction I am talking about. And the properties, let us say the properties when I am saying physical properties and mechanical properties, since we are mechanically discussing everything. So, I am let us say I am talking about E. Young's modulus, which all of us we are very much popular, the E term is popular with us. So, this E, if I am saying this E, let us say E1 in this direction, this direction, this direction, this direction are same in all direction. Similarly, the E at P1, P2, that means E at P1 or P1 at E at P1 and E at, I can write in this way, P1 E at P1 and P2 P3, they are same in all direction, but there is a chance that this E at P1, this E at P2 may not be equal. That means, if I am going from one point to another point, they are same in all direction at point 1, they are same in all direction in point 2, they are same in all direction in point 3, they are same in all direction in point 4, but this P1, the E at P1, E at P2, E at P3, E at P4 are not same. That is possible, that means it varies with the space. As I am going along the length, along the any direction, either length or breadth or width or thickness, whatever I am saying, if I will go in that direction, there might be a chance that they are going to change. But in case of homogeneous, it is the E at P1 has to be equal to E at P2, E at P3, all the directions it has to be same. Then if it is not varying with the, it is a space invariant and it is space variant. Anisotropic, if it is the material properties are changes or varies in all the direction. Orthotropic, if the material properties are same or directionally changing. Normally we represent any kind of space, it is called Euclidean space, and that space, any kind of space, when I am saying all kind of space, when I am saying, that means x, y, z, if I will say the E along x, the E along y and the E along z, they may be same at any point within the line, and this E is same, that means Ex along the x as well as all the direction about the x may be same, but E2 may not be, E1 is same along the x or E is same along the x, E is same, or I say it is E1, I say it is E2, I say it is E3. This is Z, this is, let us say, I am saying, sorry. So, it is E3. Now, E1 along x, E2 along y and E3 along z are same, but E1 is not equal to E2 and E3 is not equal to E2, likewise they three are not equal, but E1 is same in all direction. So, they are directionally changing, or orthogonally they are changing, material which has properties same in all perpendicular direction or orthogonal direction. That means, it is orthogonal, E1 is same, E2 is same, but E1 is not equal to E2, E2 is different, and orthogonally they are, perpendicularly they are same, but they are not individually, they are not equal. And some more cases of material can also be divided into, like elastic, as it has been said, elastic, elastoplastic, the plastic. This is a one kind of broad classification I have shown. These are all other kind of broad classifications also can be shown in ductile, brittle, based on their property, what is ductile material, what is brittle material. You please see other materials, as I said. Also you can see some kind of NPTEL, all these courses for that also, or some Google also, you can do some Google, because most of us we have now, we are having this one Geo Dhan Dhanadhan. So, you can use that to utilize or to focus on a different part. Now, mechanics, what is the basic of mechanics and what is the basic of materials we have discussed. Now, we will come to the loads. As I said, the mechanics deals with the force as well as the displacement, or the force, cause and effect. Similarly, the load or the force, are they synonyms? Yes, they are, although they are not been used, but the loads can be classified. I can say the force, can I say load and force are equal? Yes or no? If it is yes or it is no, you please let me know it is yes or no. You also see, then slowly we will discuss about that. So, how they are different from each other or they are same. Sometime we say the loads are also classified, as it has been said. You can see the classifications: normal, shear, couple and complex. Complex, when I am saying, it is combination of one or many. Combination of normal to shear, or combination of shear to couple, or combination of normal to couple, or combination of normal, shear, couple, all are is a complex type of loading. When I am saying normal again, normal is basically talks about the perpendicular loading or transverse loading, and shear is parallel loading, and couple is either bending moment or torque. Wherever you will go or wherever any kind of load will be there in a we know every material in this world exists in 3 dimension. So, any load which is perpendicular to one direction, it may be perpendicular to other direction, or it is parallel to one direction, then it may be parallel or perpendicular to other direction as well. So, if there is a tensile load or a compressive load or a bending moment or a torque, they are coming under all these classifications will come under the loads. And most of the part in our whole analysis, you will see initial phase of the analysis we will talk about the majority, in majority we will talk about the tensile, then a part of the load will talk about the bending moment, a part of the discussion, a small part of the discussion will also come under the compressive loading, and I will also discuss the very first part of the course what kind of load will be associated with this analysis. And a torque, in total a torque is a different chapter is given, and in bending moment also a different chapter is given, but compressive nowhere any chapter is defined, but we will discuss about that, and during my discussion I will say which part is specifically designed, or I am just saying it is buckling part is mostly the compressive kind of load. All the other analysis both bending and torque majority we use tensile load. Now, this is the classification of the load, and load can be classified in other way also, not only the normal shear couple, there are some more forces like internal forces, external forces, surface forces and body forces. In majority we define the loads or the forces either a surface force or a body force, whatever the kind of force. One is internal force as it has been written, the external force also they can be called as a surface force or body force. If any force which is throughout the volume as it has written gravitational and magnetic, if the force which is acting on a body which is gravitational and magnetic, that means it is acting throughout the body, gravitational, magnetic, electrical, all these forces throughout the body or throughout the volume. If the force acting on a body throughout the volume, it is called body forces, it is within the body. Any mechanical forces, pressure, external force, hydraulic force, atmospheric pressure, it is on the surface only. So, it is surface forces. And if it creates the state of stress strain in body arises due to external influence, that is called external force. And if it is arises due to external forces is applied, a reactive force or internal forces or reactive forces develops within the body. We know every action has equal and opposite reaction, and due to the reactive force, if any due to the reactive force or the reactive forces which are generated within the body also called as the also classified or under this internal forces. The mechanics of material basically utilizes these 4 kind of forces. And again this mechanics of material, although the mechanics of material we can also classify in a single line. If I want to classify how the mechanics is different than the mechanics of material, or how the mechanics of material is different than the mechanics deals with the rigid body, whereas mechanics of material deals with the deformable body. Mechanics does not talk about the internal behavior or internal straining or internal deformation of a body, whereas the mechanics of material talks about or takes into account the within the body if any straining is occurring. And what is strain? We will talk about, it is a more interesting, the strain part is more interesting. When we will come to the strain part, and differently I will talk about the stress as well as strain. Now we are discussing about the stress, and the stress comes due to the, all of us we know the stress pressure is due to the applied force per unit area and all this. So, how this applied force, how the force is different than the stress, and how the pressure is different than the force, all this we will discuss slowly we will discuss about that. And load also can be defined based on the time. Sometimes they are called dead load, sometimes they are called active load, and the dead load or active load based on the time. Static load, it is gradually applied load, equilibrium reached in a very short time. Sustained load acting on the body for a long, sustained as it is sustained for the long period, that means due to that which creep occurs. And a thermal creep, I am just giving a example, you give me a example, a thermal creep, just see what is example of a thermal creeping or process of creep, thermal creep. The making of ice is one kind of thermal creep. Thermal creep is a low temperature creep. it is not high temperature creep. At low temperature you are putting this body for a longer period of time and it is slowly it condensed, the water condensed to the ice. So, it is also a creep kind of loading. It is like starting and different sense under particular circumstances like impact load. Impact load, most of us you know what is impact, and because every day in Indian roadways if you will go, so you will all kind of impacted are there. So, impact load, it is rapidly applied load such as load applications will cause vibration, body on less vibration dies down, equilibrium will not reached. And repeated load, I no need to discuss more and more because it is again repetitive. If I will repetitive load itself it is repetitive in nature. Now, with respect to area, with respect to load, also load can be with respect to over which load is applied according to the area, it is changing or distributing type or variable type or a concentrated type accordingly. But I am telling you very fact, one fact is that there is no such in engineering, there is no such load is called concentrated load. So, that is why it is written as with respect to area over the which load is applied. That means, if a person, if you will see, if a person is standing on his feet, when a person is standing on his feet on a bridge, let us say, if I am saying it is on a bridge he is standing, on a road he is standing, and if the road, if I am talking about, how I can say it is a point load, I cannot say point load. On a bridge, if I will talk about, let us say, if on a bridge a 1 kilometer or 500 meter bridge, and on that 500 meter the projected area of a human being like that, and now the social distancing is going on, and the social distancing every 2 meter one person is standing. If I will talk about the length as compared to its projected area, it is just like a point on that line. But originally there is he is on area, the total load is coming on area, but if I will compare that area with respect to the beam length, it is negligible. So, when it is negligible, I will consider this as a point. So, it is concentrated at a particular point. It is just a replication of that. It is not that a point load is acting. There is no such point load concept is that, only to convert or engineering application or to have a simple analysis we make it concentrated load. Otherwise, there is no such concentrated load in macro mechanical stage, but for the analysis point of view we did that, or we normally do that. Now, distributed load, this kind of load you can say what kind of distributed load. Distributed can be evenly distributed, non-evenly distributed, uniformly distributed, non-uniformly distributed, on the area it is distributed, on the length it can be distributed. Let us say if I am taking a bridge, on a bridge, a 1 kilometer bridge, on that bridge there are 10 number of I-10 cars are standing, or it may not be possible every time the I-10 car is there. If 10 number of I-10 car are standing at a 1 meter distance, all are assumptions I am talking about. So, if one I-10 car is standing, then it is uniformly distributed up to 5 meter, they are uniformly distributed. Here one I-10 car, one 6 wheeler, one 12 wheeler, likewise if I will change, then they are non-uniformly distributed or they are changing. So, accordingly also load can be changed or load can be incorporated in the system or any analysis. As I said initially, just remember every time it is an analysis swing, and how to analyze, we are just putting, these are the stepping stone we are writing or we are discussing, these will be pointed out when we are going to solve any problem. Is that clear? Now, I will go to the next part. As I have already mentioned, I no need to discuss much, just to have a completeness all this kind of loading and all. So, torsional load, bending load, which we have discussed in the first slide, the classification, here some of the kind with respect to location and method of application has been discussed. Now, as it has been said, the mechanics of material is basically or strength of material basically obeys the laws of mechanics, or it works on mechanics. But mechanics, what kind of laws mechanics obeys? Now, all the forces and moments equal to 0, equilibrium equation, because every material or every design or every kind of concept starts with to find out the unknowns. In order to find out the unknowns, we need to analyze the force and their cause, and whenever the force is applied, that may be external force, that may be internal force, all kind of forces. Here we are dealing with, in mechanics of solids we are dealing with the internal forces including the external forces. whereas in mechanics only we are talking about the external forces, there was no internal forces. So, that is why it is different than the mechanics. That is also one second difference. First one was the mechanics is different how. Now, it is a resistant body, it is for deformable body, it is not considering the internal strain, it is considering the internal strain. And in now we are talking about the it is associated, mechanics is associated with the only external forces, and mechanics of material associated with the external forces as well as the reactive forces develops within that. Both will be considered, but it obeys mechanics of material, since it is associated with the name of mechanics. So, it obeys also the laws and axioms obeys by the mechanics. Any analysis, first of all we know from the mechanics, if a dynamic system we have to make a pseudo force, utilizing a pseudo force we make it in equilibrium. So, first point of any material or any design, the material or the object has to be in equilibrium state. And the second part is there is a, if I will go in terms of mechanics of material term, it is stable and equilibrium. The every material and object should be in a state of stable and equilibrium state. If it is stable and equilibrium, then only the design is stable, or a unstable design will come into the picture. In Indian context, instability is everywhere. You can see on the different structure, unstable structures are there. Every year you might have heard about when you are looking some buildings during this rainy season, some of the buildings are need to be smashed due to the instability because of very old buildings, and likewise some of the other structures also comes in the instability condition. So, the structure has to be stable and equilibrium. We will come to that slowly when I will discuss all different kind of examples, I will come into that. The members are in equilibrium, and the static equilibrium talks about all the forces and moments equal to 0 in all the direction. This is the major part for any static equilibrium condition. It obeys the static equilibrium condition are applied to the force acting to some part of the body in order to obtain the relationship between external forces acting on the members and the internal forces. As I said, it is both it is taking consideration into both members, obtain the relationship between the external forces acting on the members and the internal forces resisting the action of the external loads, how it resisting that force, because that also very much important in this case. Now, important assumption is in mechanics of material are that body which are being analyzed in continuous, homogeneous and isotropic. I said earlier this homogeneous and isotropic will find every single step, and one more case is called continuous, which I have discussed during the very first slide when I have discussed about the mechanics, classification of the mechanics. We are talking about the continuum body. If it is a continuum body, this continuum body has to be when I am talking about the continuum analysis, any continuum or any continuous body. So, this body has to continuous, that means if I am talking about a beam made up of any conventional material, when I am saying a beam, it may be a mild steel, it may be a aluminium, or it may be a plastic beam, but is the plastic beam is the same as the case of aluminium? No. So, that is why we are discussing this mechanics of material, how it is different. For the mechanics of material will tell us how the mild steel beam will or the conventional material how they behave, as well as the unconventional material. But every material, if I will take a wire of this from this beam, if I will draw a wire from this beam, if I will just see n number of masses on the beam are associated with each other, very closely packed masses are with each other, and they are continuous in nature. And if there some void is also there, that void in between the gap between the layers, that void also not much affecting on that. Now, a body is homogeneous if it has identical properties at all points, entire volume, that is called, I have also already discussed, I need not to discuss more. A body is considered to be isotropic with respect to some properties when that properties does not vary with the direction or then a property which varies orientation, varies with direction or orientation, a property which varies with orientation with respect to some system of axis is said to be anisotropic. All the deformation in the material are small, or you just remember it is infinite small. Infinite small means when all of us we know, elasticity, that means when I am applying a load on a body, the mild steel, this kind of Hooke's law you might have already studied, this stress versus strain or load versus deformation. Stress versus strain or load versus deformation, this is a stress strain diagram, or load versus deformation also the diagram will be utilized to find out the it is the infinite small, that means when it I unload within the elastic limit, when I will unload the material, it comes to its original position. It is very small, the straining within the body is so small that when I will unload the material, it comes to its original position. Now, it holds the Saint Bernard's principle, it is obeys principle of superposition. What does it mean by principle of superposition? I think you have already, most of you have already utilized principle of superposition in the mechanics. And Saint Bernard's principle talks about the intensity. Let us say if I am taking a beam, I am applying a load at here, a simply supported beam, I am applying a load at one point, and if I am applying, let us say it is 5 meter or 3 meter beam, let us say the beam length is 3 meter and I am applying the load from the right side at 1 meter. Now, the intensity of the load will be effective near about the area, a localized area of the beam is much more intensified as compared to the, if I will go distance some distance after 2 meter or after 1.5 meter or 2 meter, if it is after 1 meter, so rest is 2 meter. If I will come this point, then near about 2.5 meters I may not get the intensity of the deformation or intensity of that load here. So, it is intensified, the Saint Bernard's principle says the deformation is near about the area is much as compared to when the load or the displacement or deformation pattern, if you want to see the farther from the load, it is lowering down. Now, with respect to static equilibrium condition, some assumptions has been shown here. A free body diagram, all of you know what is free body diagram, how the free body diagram we normally do. Let us say if I am considering a body and this is called a this plane is a imaginary plane, it is just like a knife. If I am cutting by a knife to a body and the knife is basically is a imaginary body. Here this knife kind of plane is passing through the body and it is cutting into two halves, and on these two halves you just see the A, B, C, three different part has been shown. These two forces are earlier there, it is already there, F1 and F2. The other forces which is coming out, these are the internal forces. All these forces are internal forces due to the cutting of the body. And the other half also some moment, it may create some moment, or it has been written as moment, it may be force, it is not like that, it is always moment. So, some forces and moments will be created, not only the external forces, but the internal forces are also coming out as it has been shown here. The best way account for these forces to draw the free body diagram or body's free diagram, whatever it is says. The same thing whatever I have discussed earlier point, it has been said here. Consider a body which is held in equilibrium by 4 forces shown in figure A, by which 4 external forces are there. In order to obtain the internal forces acting on the specific region, then you just it is necessary use method of section. You have sectioned that, requires that an imaginary section cut by made through the region where the internal loading have to be determined. In figure B, it can be seen that, as we have just now seen, that internal figure B, which are showing the all this cutting of that and internal forces is coming out. Exposed area section, these forces represent the effect of material on the top part of the part acting on the material of the bottom part. One is top part and one is bottom part, all through the exact distribution of internal loading may be unknown, because we do not know how much force is going to generate. Internal forces to find out the internal forces is difficult. So, these are the all through the exact distribution of the internal forces may unknown. Now, the stress will be discussed in the next class, the very first part, and now I am closing my class here, and the next class will talk about the stresses.